You've definitely heard the word blockchain, right? It's usually thrown around with things like Bitcoin. But what is it really? It's one of those tech buzzwords that everyone knows, but almost nobody can explain in simple terms. Well, that's exactly what we're going to do right now. We're going to break it down piece by piece.
So, to really get why blockchain was even invented, we have to start with this huge, tricky question that bugged computer scientists for years and years. How in the world do you create digital money that can go directly from me to you with no bank, no PayPal, no middleman of any kind? And at the heart of that puzzle is something called the double spending problem. Think about it like this. If I have a real dollar bill and I give it to you, well, I don't have it anymore. Simple. But with a digital file, like an MP3 or a photo, I can just copy and paste it a million times. So how do you stop someone from spending that same digital dollar over and over again? And then, bam, in 2008, this paper just drops out of nowhere, published by a totally mysterious person or group that only called themselves Satoshi Nakamoto. It introduced Bitcoin, and it was the very first form of digital money that solved that double spending problem without needing a central bank. And the incredible technology that made it all possible, that was the blockchain.
Okay, so what is this groundbreaking technology? Well, at its core, the big idea is actually way simpler than you might think. The absolute best way to understand it is to forget about all the complex code and just picture it as a very, very special kind of shared notebook.
This quote really nails it. Picture a single document that's been copied onto thousands of computers all around the world. Everybody can open it up and see everything that's ever been written in it. But here's the key. Nobody, not a single person, can go back and secretly change or delete what's already there. It's a shared record of the truth that everyone on the network agrees on. And that leads us to the more, formal definition. A blockchain is a shared, immutable digital ledger. Okay, let's break that down. A digital ledger is just a fancy term for a record book, like an old-school accounting book. Shared means that that book is copied and spread out across a massive network of computers. And immutable, this is the magic word, means that once something is written down in that book, it's there forever. It cannot be changed. The name blockchain isn't just some techie buzzword. It literally tells you exactly how it's built. It's made of digital blocks of information that are all linked together to form a chain. So let's see how that actually works. All right, first up, the block. The easiest way to think of a block is as a single page in our digital notebook. It's just a container that holds a whole bunch of the most recent transactions that the network has confirmed are legitimate. Next, we have the hash. Now this is where the real magic happens. A hash is basically a unique mathematical fingerprint for any piece of digital data. Every single block gets run through this special algorithm, and it spits out a totally unique code. It's hash. And what's so critical is that if you change just one tiny comma inside that block's data, the hash will change completely. So how do these blocks and hashes actually form a chain? It's a beautifully simple and incredibly secure process. First, a new block gets created with a fresh batch of transactions. Then, that block gets its own unique hash, its fingerprint. But here's the kicker. That new hash is then included in the next block that gets created, and that simple step creates a secure, unbreakable link between them. It's literally a chain, where each new block locks in the one before it. Okay, now that we know how it's built, let's get into the secret sauce. What makes a blockchain so fundamentally different from, say, a regular database that your bank or any big company would use? This is where the real power is. Honestly, the best way to see the difference is with this comparison right here. A traditional database is kind of like a private diary. It's controlled by one person or one company, and they can go in and edit, change, or delete entries whenever they want. A blockchain, though, is like a shared public ledger. Everybody has a copy, and once an entry is made, it can never be erased. That simple difference changes everything. And this unique structure gives blockchain 3 core properties that make it so powerful: decentralization, immutability, and transparency. So let's dig into each one real quick. First up, decentralization. Unlike a bank, which keeps its ledger on its own central servers, a blockchain is distributed. There are thousands of copies of this ledger on computers, called nodes, all over the world. This is huge because it means there's no single point of failure and no single person or company in control. And this decentralized design is the genius part that leads directly to that second key property, immutability, which, again, is just a fancy way of saying it's pretty much impossible to change. Let me show you exactly how that works. So let's imagine a hacker wants to get clever. They try to go back in time and alter an old transaction in, say, block 2, maybe to erase a payment they made. Well, the very instant they change any of that data, the block's unique hash, its digital fingerprint, changes completely.
And remember how each block contains the hash of the one before it? Well, because the hash of block 2 has now changed, it no longer matches the reference that was stored in block 3. The chain is broken. The cryptographic link is snapped, and it's like a giant red flag that alerts the entire network that something's wrong. So for their fake change to actually stick, the hacker would have to recalculate the hash for that block and for every single block that came after it, and then update all of that on thousands of computers across the network all at the exact same time. I mean, it's just practically impossible. The amount of computing power it would take is astronomical, making the blockchain incredibly secure. Okay, but this brings up a pretty big question, right? If there's no boss, no central authority, how does this giant network of computers all agree on which transactions are valid and which new block gets to be added to the chain? Well, the network does this using something called a consensus mechanism. You can just think of it as the official rulebook. It's a set of pre-agreed rules that lets all these different participants come to an agreement, making sure everyone is working off the exact same version of the ledger. The original and by far the most famous consensus mechanism is called proof of work. In the system, really powerful computers called miners all compete against each other to solve an incredibly difficult math puzzle. The very first one to find the solution earns the right to add the next block of transactions to the chain, and as a reward for all their effort, their work, they get some newly created cryptocurrency. It's a system that both secures the network and validates transactions at the same time. Okay, wow. We've covered blocks, chains, hashes, decentralization, the whole shebang. But let's bring it all home. Let's connect this back to that first problem we talked about. So what? Why does any of this actually matter?
This is how it all comes together. Because it's decentralized, you don't need a bank. Because it's immutable and cryptographically secure, it prevents that double spending problem. And because it's transparent, everyone can see and verify the transactions, which builds trust. For the very first time in history, this technology made a true, secure, person-to-person exchange of digital value possible. So here's the big takeaway. Blockchain gave us a way to trust data, and by extension, to trust each other, in a digital world without needing a big bank or corporation in the middle to vouch for everything. It started with digital money, sure, but the potential is so much bigger than that. And that's the question I want to leave you with. If we now have a system for creating trust without a middleman, what else could we build with that?